Okay, so this is going to be the last of our lessons on moles. We're going to move back to biology next week. So this is the last lesson on moles, the last calculation lesson. And we're still going to continue with drawing our tables. But in all the previous tables, the ratio has always been 1:1. And in today's lesson, we're just going to look at a few examples where the ratio is not 1:1 and what you would do with that. So I've started off with a chemical equation and I've balanced it, and I've asked how much LIF is produced from 380 grams of F2. So to start, I'm going to construct my table. Okay, how much LIF? I am asked about LIF, so I'm going to put LIF into my table. Is produced from 380 grams of F2. I'm given information about F2, so I put F2 into my table. It doesn't matter on which side of the table you put these. I just put the F2 on this side because it's on this side in the equation. It does not affect your answer in the slightest, okay? I'm going to fill in the rest of my table: mass, formula mass, moles, and ratio, okay? And the mass is what I'm going to fill in first. I'm given 380, which is the mass of F2. So I fill that in there, 380 grams. I'm getting that from my question. I'm trying to find the mass of LIF. My formula mass, okay, I need the big numbers from my periodic table. The big number next to fluorine is, what is it? It's 19, I think. Yeah, no, it is. It's 19. And the big number next to, it is 19. And the big number next to lithium is 7. Okay, so I'm going to use these numbers to find my formula mass. Okay, so the formula mass of F2, okay, I've got 2 fluorines, so it's going to be 19 plus 19, and it's going to be 38. For LIF, my formula mass is 7 plus 19, because I've got 1 lithium, I've got 1 fluorine, I add them together and I get a formula mass of 26. Okay, remember, when you're calculating formula mass, you do not use these large numbers in your balanced chemical equation, but if there's a small number in the actual chemical formula, then you do use that. So I've got F2, which means I've got 2 fluorine, so it's 19 plus 19 is 38, and the next one here is just 1 lithium, 1 fluorine, you add them together. Okay, to work out my moles, it's going to be mass divided by formula mass, which is going to be 380 divided by 38, and that equals 10. Okay, so that is my first answer. And I'm going to get marks for my step 1. I've got 10 moles of fluorine. Now I need to fill in my ratio. Okay, the big number in front of fluorine, there is none. And if there's no big number, I fill in 1. The big number in front of LIF is 2. So this is the first time that we've had a ratio that is not 1:1. Now my ratio is 1:2. And what this tells me is if I had 1 mole of fluorine, I would produce 2 moles of lithium fluoride. So I would produce double the amount of moles. 1 mole of fluorine would give me 2 moles of lithium fluoride. It's double. So if I had 2 moles of fluorine, I would get 4 moles of lithium fluoride. If I had 3 moles, I would get 6 moles. If I had 4 moles, I would get 8 moles. It's always double. In this case, we've got 10 moles. So I need to double that, and I'm going to get 20. So it's going to be 10 times 2 is 20. If I had 10 moles of fluorine, I would produce 20 moles of lithium fluoride because the ratio is 1:2. This tells me that I produce double the amount of lithium fluoride. To double something, I multiply by 2. So I'm going to get 20 moles of lithium fluoride. So in all the other examples we've looked at, we've had a 1:1 ratio. And if I said, if these numbers are the same, then these numbers have to be the same. But in this case, I do not have a 1:1 ratio. These two numbers in my ratio are not the same. Okay, they've got a relationship of 1:2. This number is twice as big as this number. So this number here needs to be twice as big as this number. 20 is twice as big as 10. It is 2 times 10. So the relationship is the same. 1:2 is the same as 10:20. So 1:2 or 2:4, 3:6, 4:8, 10:20. You need that relationship to remain the same. It has to be twice as big. Now that I've filled in my moles, I'm going to find my mass exactly the way I always did. So it's going to be the moles, which is now 20, multiplied by the formula mass, which is 26. 20 times 26 is 520 grams. So if I had 380 grams of fluorine, I could produce 520 grams of lithium fluoride. Okay? I'm going to look at another example using the same equation. And this time I'm asking how much fluorine is needed to produce 260 grams of LiF. So once again, I've got fluorine in my table because I'm asked about fluorine. And I've got lithium fluoride in my table because I'm given information about lithium fluoride. Okay, the information I'm given is 260 grams. The numbers that I need from my periodic table are 7 and 19. Okay, the formula mass of F2. Okay, again, you've got 2 fluorine, so it's going to be 19 plus 19 is 38. For LiF, you've got 1 lithium, 1 fluorine. You add them together, you get a formula mass of 26. To calculate my moles, it's always mass divided by formula mass. It's going to be 260 divided by 26, and that equals 10. Okay, to fill in my ratio, the big number in front of F2, there isn't one, so I just fill in a 1. The big number in front of LiF is 2, so I fill in 2. Okay, so once again, I've got this 1:2 ratio, but this time I'm trying to find out the number of moles of fluorine. Okay, so if I look at my ratio, I can see that again, I need double the amount of moles of LiF as I need of F2. So I need twice as many moles of LiF as I need of F2. If I have got 10 moles of LiF, then that means I will need 5 moles of F2. Okay, so if we look at the ratio, 1:2, this number is 2 times bigger than this number. And the relationship here is the same. 5:10, this number here, 10, is twice as big as 5. If you want to look at it the other way, 1 is half of 2, 5 is half of 10. If I wanted to continue that ratio, using different numbers, I could have 4 is half of 8. I could have 2.5 is half of 5, okay? But all of these numbers have to be in the same ratio. And these are just random things I'm making up, okay? These numbers have to be in the same relationship. And I'm getting this 1 because there's no number in front of fluorine. I'm getting this 2 because there's a big 2 in front of LiF. This number here I calculated, 260 divided by 26 is 10. And this number that I'm filling in, to fill it in, I need to make sure it's in the same ratio as what I have here. In this ratio, this number here on the left is half the number that's on the right. The number on the right here is 10. Half of 10 is 5. So I'm going to fill a 5 in there. And then it's going to be 5 multiplied by 38 equals 190 grams of fluorine. So if I wanted to make 260 grams of lithium fluoride, I would need 190 grams of fluorine. Okay, we're going to do another one together and then I'll get you to do some by yourself, okay? So I've asked how much H2 is needed to react with 140 grams of N2. And I'm going to start by drawing my table. And I'm asked about H2 and I'm given information about N2. So I'm going to put both of those into my equation, or into my table, and then I'm going to write down mass, formula mass, moles, and ratio. The mass of nitrogen is 140 grams. So I'm given that in the question, all right? And I'm trying to find out how much hydrogen would be needed. To calculate the formula mass, I would need big numbers from the periodic table. N is 14, H is 1. Okay, so to find the formula mass of H2, remember we do use these small numbers. I'm going to have 1 plus 1 equals 2. So each hydrogen has a mass of 1. You've got 2 of them. Formula mass is 2. For N2, each nitrogen has a mass of 14. You've got 2 of them, which gives you a formula mass of 28 in total. Okay, I'm next going to find the moles of N2. It's going to be the mass, which is 140, divided by the formula mass, which is 28. And I get an answer of 5. Okay, 140 divided by 28 equals 5. And that is my number of moles of N2. That's going to get me my first mark. That's the step 1. I now need to fill in my ratio. The big number in front of H2 is 3. So I write down a 3. The big number in front of N2, well, there is none. So I just write down 1. So now I've got a ratio here of 1:3. This number here is 3 times bigger than this number, which means this number has to be 3 times bigger than this number. Okay, so to get from 1 to 3, I would need to multiply by 3. 1 multiplied by 3 is 3. To get from 5 to my answer, I also need to multiply by 3. It's going to be 5 times 3 is 15. Okay, so these numbers are all in the same ratio. This number is 3 times bigger. 1 times 3 is 3. So this number needs to be 3 times bigger than this number. 5 times 3 is 15. They're in the same relationship. 1:3, 5:15. You've always got a number that's 3 times bigger on the left than the number you've got on the right. Once I know my moles, I need to find my mass. To do that, it's moles times formula mass, which is going to be 15 multiplied by 2, 30 grams. So if I had 140 grams of nitrogen, I would need 30 grams of hydrogen to react with it. So this one I want you to do for yourself. I've started it off for you, okay, and I'm asking you how much chlorine, Cl2, is needed to produce 585 grams of NaCl. So I've put chlorine and NaCl into the table. I filled in the 585 under the NaCl, and I've calculated your formula mass for you. What you need to do is you need to find your moles, you need to fill in the ratio, and then you need to use the ratio to find the moles of chlorine, multiply it by formula mass, and find your mass. Okay, so press pause, have a go at this by yourself, and then press play. Okay, so I filled in the answer, all right. To find the moles of NaCl, it's going to be mass divided by formula mass, which equals 10. Okay, then I fill in my ratio. The big number in front of NaCl is 2, so I fill in a 2. There's no big number in front of Cl2, so I just fill in a 1. My ratio is 2:1. This number on the left is half of the number on the right. So this number here on the left must be half of the number on the right. To find half of something, you divide by 2. So 10 divided by 2 equals 5. Now you can see that they're both in the same relationship. To get from the left to the right, you would multiply by 2. 1 multiplied by 2 is 2. 5 multiplied by 2 is 10. Or to go from right to left, you would divide by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. These numbers are all in the same relationship. Okay? Once I know that I've got 5 moles of Cl2, I multiply it by the formula mass, 5 times 71, and I get 355 grams. Okay, have a go at this one. How much sodium is needed to completely react with 142 grams of Cl2? So I filled sodium and Cl2 into the table. I put the 142 at the Cl2, and I filled in your formula mass for you. You need to calculate the moles. You need to fill in the ratio. You need to use the ratio to find the moles of sodium, and then you need to find your mass. So press pause and have a go at that. Okay, so I filled in the answer, right? 142 divided by 71 means you have got 2 moles of chlorine. So it's 142 divided by 71. I have got 2 moles of chlorine. Now I need to fill in my ratio. There is no big number in front of Cl2, so I just write down 1. There is a big 2 in front of sodium, so I write down a 2. This relationship is 1:2. The number on the left is 2 times bigger than the number on the right. So this number here must be 2 times bigger than this number here. To get a number 2 times bigger than 2, you multiply 2 by 2, and you end up with 4. Okay, so the numbers on the left are twice as big as the numbers on the right. Or you could say the numbers on the right are half the numbers on the left, but the relationship is the same. 1:2, 2:4, 3:6, 4:8. Okay, the relationship is the same. Once I know that my answer is 4 moles, it's going to be 4 multiplied by 23, which is my formula mass, and I get an answer of 92 grams. Okay, I'm going to give you a few more of these to do where I fill in none of the table. So you basically need to be able to find your formula mass yourself. You need to pick out what's important yourself. You basically just need to do everything yourself. I'm just going to give you 3 of them to practice, 4 of them to practice with a mixture of different ratios, and just try your best. So do the 4 questions by yourself, and then right. So here are your questions. There's 4 questions in total. Question 1, you are given your chemical equation and you're asked 2 questions, A and B, which both relate to the same chemical equation. Then I give you a different equation in 2, and I ask you 2 questions, A and B, about it. For each one, you are going to need to draw a table. You need to decide from the question what needs to be filled into that table. You need to calculate the formula mass. You need to figure out the ratio. You're doing everything yourself, okay? So I'm going to give you the numbers that you would need. For potassium, it's 39. And for bromine, it's 80. And for this one down here, nitrogen is 14 and hydrogen is 1. So they're the numbers that you will need for your relative formula mass. Okay, all other information that you need is given to you in the question. Don't be intimidated by having to do everything yourself. Just look back on the previous examples. We've used both of these equations before in the past. So just look back on previous examples and try and build it up yourself. Press pause, spend some time doing all 4 of these, and then press play when you're ready to see the answers. Okay, so I'm starting here on 1A. I filled in the start of the table. I'm about to fill in my ratio. If I look at my chemical equation, I've got a big number 2 in front of a K and a big number 2 in front of the KBR. So I'm going to write 2 and 2, and I'll simplify that to 1 is to 1. Okay, my formula mass, big number next to K is 39. Here, I've got a K and I've got a bromine, so it's going to be 39 plus 80 is 119. To find my moles, it's going to be 200 divided by 39, which equals 5.13 to 2 decimal places. My ratio is 1 is to 1. If these 2 numbers are the same, then these 2 numbers are the same, so this will also be 5.13. And to calculate my final answer, it's going to be 5.13 times 119, and that equals 610.47 grams to 2 decimal places. So if you got that as your answer for question 1A, well done. Remember, I'm rounding all of these to 2 decimal places. So if you did 200 divided by 39 and you didn't round, so if you left it like this and then you multiplied it by your 119, your answer is going to be slightly different than mine, but it's not wrong. It is still correct. Okay, so you can add either 610.47 or 610.26 to 2 decimal places. Please keep them to 2 decimal places. Okay, so in 1B, I'm looking at bromine and I'm looking at potassium bromide. I started by filling in my formula mass. I've got 2 bromines. Each bromine has a mass of 80, so 80 plus 80 is 160. And then I've got my potassium bromide like I did above. To find the moles of bromine, it's going to be 480 divided by 160, which is going to give me an answer of 3. Okay, then I need to use my ratio. I go up and see that there's no number in front of BR2, so it's going to be a 1, and there's a big 2 in front of KBR, so I'm going to have 1 is to 2 as my ratio. Okay, this number on the right is 2 times bigger than the number on the left, so this number has to be 2 times bigger. So it has to be 3 multiplied by 2 equals 6. Okay, the relationship has to be the same. 1 is to 2, 3 is to 6. Each time I am doubling the number on the left to get the number on the right. If I have got 6 moles, then it's just going to be 6 times 119 equals 714 grams of potassium bromide. That is my final answer. So well done if you got that as your final answer. Okay, I'm going to go through questions to A and B. So I've started off to A. I am asked how much nitrogen I would need to make 100 grams of NH3. So I have already calculated my formula mass. The big number next to nitrogen is 14. You've got 2 nitrogens, so 14 plus 14 is 28. Here I've got 1 nitrogen, which is 14, and 3 hydrogens. Each hydrogen is 1, so it's going to be 14 plus 1 plus 1 plus 1 equals 17. To calculate my moles, it's going to be 100 divided by 17, which equals 5.88. I'm rounding that to 2 decimal places, okay? And then I look at my ratio, and the big number in front of NH3 is 2, and the big number in front of N2, there is none, so it's going to be 1, okay? So again, I've got a 1 is to 2 relationship, okay? The number on the left is half the number on the right, okay? So what I need to do to maintain this relationship is I need to get half of 5.88. To do that, I'm going to divide by 2. So it's going to be 5.88 divided by 2. And I'm going to clear my calculator and do 5.88, just 5.88 divided by 2. And I'm going to get 2.94. Okay, if you didn't clear your calculator and you had your 100 divided by 17 and you had that whole big number and then you divided that by 2, that's fine. But your answer is going to look, oh no, actually your answer will look the same as mine, 2.94. Okay, once I know my moles, I multiply it by my formula mass. So it's going to be 2.94 times 28. And I get an answer of 82.32 grams. And that is my final answer. That is the amount of nitrogen I would need if I wanted to make 100 grams of NH3. Okay. So again, with the ratio, it's harder to see because I'm using kind of, decimal places, but the relationship here between 1:2 and 2.94 to 5.88 is the same. To get from 1 to 2, I would need to multiply by 2. To get from 2.94 to 5.88, I would need to multiply by 2. Or if you're going from the right to the left, then you're dividing by 2 each time. 2 divided by 2 is 1. 5.88 divided by 2 is 2.94. So the relationship is the same. Okay, last one. I've got the mass of nitrogen as 168 grams, and I want to know how much hydrogen I would need to react with 168 grams of nitrogen. I work out the formula mass of my nitrogen, N2. I've got two nitrogens. So 14 and 14 is 28. With H2, I've got two hydrogens. Each one has a mass of 1. 1 plus 1 is 2. Then I do my moles, which is going to be 168 divided by 28, which gives me an answer of 6. Okay, I've got 6 moles of nitrogen. The ratio, the big number in front of N2, there isn't one, so I just write down a 1. The big number in front of H2 is a 3. This is the 1:3 relationship. This number here on the right is 3 times bigger than the number on the left. Okay, to get from the left to the right, I would need to multiply by 3. So to get from 1 to 3, I would need to multiply by 3. So to get from the left to the right up here, I will also multiply by 3. And 6 times 3 is 18. Okay, so I've got 18 moles of H2. Once I know how many moles, I'm multiplying 18 times 2. Oops. I should be able to do this in my head. I can do this in my head. I don't need to use my calculator. 18 times 2 is 36 grams. So if you're starting with 168 grams of nitrogen, you need 36 grams of hydrogen for a complete reaction. Okay, so actually I think that little arrow is quite helpful. I'm going to do it up here as well. To get from 1 to 2, I would need to multiply by 2. So to get from this side to this side, I also need to multiply by 2. Okay, the relationship has to be the same between the numbers in your ratio and the numbers that you've got in your moles. All right, so that's all we're going to do on moles, just solving these types of questions using our table and using a number of different ratios. 1:1, 1:2, or 1:3. I'm not going to give you any ratios more complicated than that. This week's homework will be based on this. I'm going to do it in 2 sections. There's going to be section A that everyone has to do. And then I'm going to do a section B, kind of a challenge section for those of you who find this really easy and who want more difficult questions. So section A is compulsory for everyone. You all have to do section A, but section B is optional and you only have to, you should do it. You should do it. It is optional, but do it if you are finding these calculations easy and you want a bit of a challenge, okay? So section B is optional, but I do want to see some of you do it. I know from the work that you've been sending me that you're more than capable of having a go at the questions in section B. So I do want to see some of you doing section B, even though it's not compulsory.